All right, so the first thing we're going to look at, we're going to do, it's either 5.1 or 6.1, like I said, depending on the book. But it's basically looking at applications of integration. So as you saw when we were looking at in Calc 1, you saw that integration tells you the distance from the curve to the x-axis. So it's giving you the area underneath that curve, where differentiation is giving you the slope of the curve. When we're looking at multiple curves, we have to figure out, we're looking at the area between those curves, we have to either add or subtract. So as you can see in this example here, we have curve f of x on the top and g of x on the bottom. And we're looking at the area between those two curves. All the formula is f of x minus g of x. Now, in this case, they gave you a and b. So they're looking at it between those two, the start and end points. Those start and end points can be anywhere. When a lot of times when you're looking at it, is you're looking at to where they cross. So it'd be over to like this point right here, and then the point over here where they don't show you. But the concept works the exact same way. So it's really just subtract the two functions and find the integral of that new function. So there's the equation right down there. A little bigger. So we have area equals. We got f of x minus g of x. Yeah. So that's the integral that we're going to be working with. When you're looking at it, the f of x is your top equation and the g of x is your bottom. That's important. Otherwise, you're going to get a negative value and it doesn't make much sense. So f of x is your top and g of x is your bottom. Because of the way it works, it doesn't actually matter if it goes above or below the line here, so the x-axis. All right. All these slides are saved, so like if you need questions or anything else, want me to go back, just tell me, I can switch them back. It's not a big deal. All right. All right, let's look at a problem. So we've got these two equations. We've got y is e of x and y is x. And it's bounded between 0 and 1. And they want to know the area between those two functions. So we'll set this to be f of x and that to be g of x. So integral, we're going to go from 0 to 1. And then it's e of x minus x dx. All right. Now let's just do the integral of it. So what's the integral of e to the x?
I might be getting this wrong. It's e to the x.
Yep.
Okay.
The integral of e to the x.
I forgot the basic.
No, that's right. Yeah, the integral of e to the x is e to the x. And now the integral of x is? This is that review. This is the digging up of the old things.
1/2 x squared?
Yes, 1/2 x squared. All right. Now, we don't have to worry about the plus c because this is a definite integral. So we're doing it from 0 to 1. So I have e to the 1 minus 1/2 1 squared minus e to the 0 minus 1/2 times 0. Now, a lot of times, your 0 is going to cancel itself out. Not in this case. I got to write smaller. All right, so I've got e minus 1/2 minus 1, and then plus 0. So it ends up being e minus 1 or 3/2 is the final answer. So that's why I say this section, the integrations are going to be very simple to do, just really remembering those rules and stuff. So it's good practice. And that's a completely acceptable answer with the E in there. You don't have to break it down any more than that. All right, let's look at another one. All right, so now this one says find the area of the region enclosed by these two parabolas. So we'll set, we have y equals x squared and y equals 2x minus x squared. So I need to figure out which one's going to be my f of x and which one's going to be my g of x. So I need to know two things in this problem. First off, I need to know which one's on top, because that's going to be the one that's going to go first. And I need to know where they intersect so that I can set those as my barriers, my A and my B. So what we're going to do is we're going to use Desmos. So Desmos, this is the graphing calculator. It's DSMOS. Great graphing calculator, easy to simple to use. There's apps for your cell phone for it, and you can use it on your computer.
My favorite part is I thought we were going to do this by hand, and I was real worried.
God, no. No. Can you do it by hand? Yes. Why?
All
We
I'm
have
hearing is
technology.
Calc 2 is better than Calc 1 just because everything's not done by hand.
Yes. Like we have technology. Why use hands when we have technology? All right, so there's my two equations. So they also color code it, which is kind of nice. So in this equation, I'm looking at where they cross. So they cross at 0 and they cross at 1. So you've got access to both those. So now we know where they cross. And we know which one's on top. The blue one's on top, which is my 2x minus x squared. So we're going to make that my f of x. And we're going to make the other one g of x. Yeah, I'm one of those teachers that, like, when you go out in the world, you're going to have access to all this. Let's use it. Do you need to know the concepts? Yes, but let's not make it harder than it has to be. All right, so there's my wonderful little graphs, and I've set the first one to be f of x, the 2x minus x squared, and the other one to be g of x. So now let's do our integration. So we have the integral from 0 to 1. And it's going to be 2x minus x squared minus x squared. So we can simplify this integral down. So I have negative 2x squared plus 2x. Yeah. So the integral of negative 2x squared is what?
Negative 2/3 x cubed.
Yes. And then x 2x. Ends up being just x squared. Because the 1/2 and 2 cancel each other out. So we're looking at this from 0 to 1. So I get negative 2/3 times 1 to the 3rd plus 1 squared minus 2/3 times 0 plus 0. So the second half of this cancels out because it's all zeros. So I got negative 2/3 plus 1, which is 1/3. All right, you should be able to do your fractions. However, if you screw up your fractions quite a bit, which some people do, Desmos can do that for you too. So the scientific calculator allows you, it'll give it to you in simplified fraction form. Like I said, so these two apps, you can download the scientific calculator and the graphing calculator, both apps that you can put on your cell phones too. So you have access to both of those. All right. Let's do a topical one. This is not the COVID one. This is not COVID. It's actually the measles. So this is the graph for a pathogen. So this is how it looks over time. So pathogen enters your body. As it's in your body, it starts building up into your body. You do not become infectious as soon as you catch it. You become infectious after a certain amount of time when you have a high enough what's the term? I'm trying to think of the term off the top of my head. I can't think of it now. Concentration. Have a high enough concentration of the virus in your body. So measles, you become infectious at about 10 or 11 days. Your symptoms appear at about 12 days. Your infectious period ends around day 17 or 18. And then by about 3 weeks, it's cleared out of your system. So they want to find out what's the level of infection for an infected person during the infections period. So right now we have one curve. We need to find the other line to block off when they're infectious. So when we're looking at this, we want to find the line from here to there. We want to find the curve just from 10 to 11. Okay, so we want to find that piece right there. The equation they gave for this curve is negative t minus 21, and t plus 1. That's the equation they gave for the curve. It's not the same curve, so the numbers won't make sense when we get the answers from this, but that's the graph I was going to use. So they want to know on day 10 and then day 18. So when we were looking for that other curve, I need to know this point and that point to find the equation of that line. So we're going to find f of 10. And here's another great use of Desmos. So we can plug in. So you can type your equation in and then put the variable. So x equals 10. And it'll solve the other equation for you. So when it's 10, the answer is 1210. And when it's 18, all we do is just change that 10 to 18. And we get 1026. So 10 was 1210. and 18 was 1026.
Excuse me, Professor. How do we get the other decimals?
It's a scientific calculator. So if you go up to the, if you click on it, or when you're on the website, just click on the math
Okay.
tools, click scientific calculator.
Thank you.
All right, so we now have 2 points. Once I have 2 points, I can find my slope, and we can find my y-intercept to come up with my equation. So to find my slope, we're going to do, doesn't make a difference which point we use. So we'll do the second point. So 1026 minus 1210 over 18 minus 10. And my slope comes out to be. So m is negative 23. And then I can use the point slope equation to make my life a little bit easier. So we'll use n minus 1210. Y minus 1210 equals negative 23 times x minus 10. So we get my equation is negative 23 x plus 1440.
I'm sorry, Professor.
Yep.
How did you end up with that?
Which
Plug
part?
that in- Oh, you pointed that in, you plugged that into the point slope equation?
Yeah. So it's the y minus y1 equals m times x minus x1.
Gotcha, thanks.
No problem. You could do it just the y equals mx plus b, plug the one of the points in and solve for b too. It would come out to be the same answer. All right.
And so this approach is better, you're saying, the point slope equation? The same.
I like it because I don't have to come up with an answer and then plug back in. Now you got to remember, I teach high school a lot of times. So my students have trouble with multiple extra steps. So by doing this equation, I solve them the problem of taking the answer that they've got and then plugging it back in, because all too often they would have gotten B and they would have put that down as their answer and stopped. So this way I get an equation out at the end. It's really a personal preference. It's which one you're better at doing.
Oh, this is completely new to me. This is I like it. It's a lot simpler.
Good. So yeah, the point slope equation is nice, especially as long as you have a point, because it just plugs in and then just solve for y. It's all done in one step instead of multiple ones. All right, so now that we've got our equations, we can look at the area beneath the curve. So if we look at this, actually, I'm going to put them both into Desmos so you can actually see the exact what this exact curve looks like. The only thing when you're using Desmos is you can't use any other letter except for X in the graphing calculator, obviously. So just keep that in mind. And we got. All right, I need this from 0 to 20. And then from 0 to. All right, there we go. The gear up, the little wrench up here, you can change your X and Y axis to whatever you want. When you zoom in and out, it's going to always zoom both directions the same way. And that's how you look. Notice like it got really crunched on one side, the X axis, because I didn't need that to go up to 2000. So you can change your X and Y axis up here, and then you can go back and just do your zooming out. So you can see exactly what you're looking for. So there's our equation. And we're looking for the curve in here. So I'm taking my negative x minus 21, x plus 1, and dividing it, and subtracting off the negative 23x plus 144. So let's look at that. So I've got my f of x is going to be negative x. What's x minus 21? And then x plus 1. And g of x is negative 23 x plus 1440. This is one of those ones that the way it's set up right now is going to be a mess to try to do the integration. So let's take f of x and multiply it across, multiply it out, so we just have it as a simple polynomial. And then my integration is going to be a lot easier to work with. So we multiply this out, we end up getting negative x to the third plus 20x squared plus 21x. So then my integral is going to be from 10 to 18. And I've got negative x to the third plus 20x squared plus 21x minus negative 23x plus 1440. So that's one of the things that when we start even looking at further on, it's getting the integral into a way that's going to simplify the solving of it. All right, we can, leaving it in factor form is nice for what we were doing a minute ago, but in an integration, we now have multiplication with subtraction, it's a mess. So if we can get it all down to a simple way to do it, that's the way we want to look at it. So just keep that in mind. All right, another.
Sorry, you just switched the equation that we were giving from t to x.
Yeah, I just changed it to x. The letter doesn't actually matter as much until you get to multivariable and you have to keep two letters separated. But using a t or an x in these problems, that doesn't make that big of a difference.
All right, thank you.
And I hate writing t's because they look like my pluses. All right, so now we got to put these two equations together to make our lives a little bit simpler. So I've got negative x to the third plus 20x squared. I got positive 21x and I got a positive 23. So I got 44x and then I got a minus 1440. Don't forget to distribute that negative sign to both parts. Very, very easy to screw that up and forget. All right, so let's do my integration. So we got negative x to the fourth over 4 plus 20x to the third over 3, 44x squared over 2, and minus 1440x. And we're evaluating that from 10 to 18. Notice I did not simplify this. I don't have to. I'm going to get an answer out anyway. So the less I found you do little things inside the problem, the less chance you have to make those mistakes. So I'm not going to look at that and go, oh, you didn't simplify in the middle of the problem, because that's not what I was looking for. We're looking for the answer at the end. So I'm going to type this in while you're doing that. I'll write it down. All right, so we can type the whole problem right into Desmos, and we're looking at it from 10. Well, actually, let's do the 18 first. So we do the 18. Mess up the sign here. Hold on a second. I did. Wait. Plus. What? I think I messed up a sign somewhere. Oh, nope, I didn't. Okay. Never mind. And then we got the -8033. Yeah, and hitting back kind of clears your screen. You have to type it all over. Start what I was doing. You plug them both into Desmos, you do the subtraction, you can do it all right on the screen, saves you a step, and the answer ends up being 1877. So you can use Desmos to do multiple things. Sometimes it's easier. It just depends on how you want to do it. I like Desmos because it actually shows you, you can actually type it in so it looks the same as when you're writing it. Where sometimes doing it on a scientific calculator, you have to have the parentheses and stuff in the right places, which kind of screws things up. So if you have a calculator that can actually type in real time, like, and it actually looks like you write, it's going to be a lot easier for you to do. So in this case, the infectious level for this patient is 1,877 cells per milliliters over days. So why I said it's topical, because if you look at that graph, the curve, it's the same concept with COVID. It comes into your system, you're infectious for sometimes before you actually show up with your symptoms, and at some point afterwards, you're no longer infectious. And if anybody's wondering about your wonderful tests and stuff like that, the difference between like the rapid tests and stuff, the PCR tests, the more sensitive ones that you take, will identify the pathogen a lot smaller in your system. So you could test positive when you're over here, and even when you're over here, where the rapid test will only tell you a lot when it's a lot more in your system. So the rapid test typically only tells you when you're actually infectious. So that's why sometimes you'll get a negative on a rapid test and then test PCR and you'll get positive. It's because the PCR is actually testing a lot smaller level of the infection in your body. So, all right. Any questions on what we did there? The actual problem was more complicated than the actual calculus.
I'm not sure what I did, Professor. I typed that into Desmos and I ended up getting a different answer.
All right, let's try. Hold on. Let's type it in and see what happens. So we got negative x fourth about 4 plus 20 x to the third 3 squared minus 40. Yeah, x equals 18. So I get negative 6156 minus well, if I kept going to 3s, they'd just come up, but that's what you should have gotten. So one of two things. Either you forgot to put the extra negative sign, which is very common.
I
Or
put
you
my
typed-
X in parentheses. Does that make the difference?
It shouldn't. Nope. Now, the question is, did you put the parentheses just around the x, or did you put the parentheses around the 20x, for example? Because that will make a difference.
No, I had put it just around the X. It's odd. I'm looking at the same screen that you are. Negative X to the 4th over 4 plus 20X to the 3rd over 3 plus
Wait,
44X
hold on.
squared.
Where's the negative sign in front of the x? Is it inside or outside the parentheses? Yeah, just parentheses shouldn't matter.
We never did get that answer.
He's trying to figure it out. I can see him. I can see him figuring it out.
Yeah, I'm astounded because I'm looking at the same screen as you are, but I'm getting negative 756. I'm using Desmos.
Share your screen.
Yeah, I was about to say.
Actually, hold on. Go ahead, share it. Let's see. Because now I'm interested to figure it out. I just gave you. You should have the ability to share now.
All right. Well, it says you cannot start screen sharing while
Oh,
the other
hold on.
participant is sharing.
There we go. Now you can.
Also, if you type in a number and don't hit like hit enter when you change any value in it, it doesn't change for you though. I did notice that.
Oh, because you have 1140 instead of 1440. There you go.
Well, that explains it then. I'm just an idiot.
Boom, roasted.
It's
Sorry.
always the little things.
Great first class.
You're fine.
Hey, look. At least you're not a guy at NASA that messed up a number and it was killed a bunch of people. Just to be
It's
fair.
true.
Or the one that screwed up the Hubble Space Telescope and cost us $700 million.
Whoa. I mean, it's
I need to hear
government's
this,
money.
sorry.
Is it even real anymore?
So, those little things. But that's the thing, like when you're doing it, those little tiny errors sometimes can make a huge difference. It really can. So, but that's why we fix things. You'd rather make those mistakes now than some other time. All right, a couple more things to do. Sometimes we're going to have so when we looked at the very first one, I said it doesn't matter. Let's go back here. If it's on the top or the bottom of the X. However, I also said that we have to subtract the one on top from the one on the bottom. Well, what happens if they switch? Then we can't just subtract the one on the top from the bottom. So what we can do is you actually can use the absolute value of it over it. So basically what it does is it just makes it all positive. Or you can do it in pieces. That's the other option you can do. You can do the first piece, the middle piece, and the last piece. So those are a couple options on how we can actually do the breaking it up of it. I like doing it in pieces a little bit better because it's a little less chance to make those little mistakes, especially when you're doing integration with absolute value, which you probably don't know how to do yet. So splitting it up is going to make your life a lot easier, which is what we're going to do right now. So we've got these two curves. We've got y is sine of x and y is cosine of x. So the first thing we have to figure out is which one's on top, which one's on the bottom. So we have it changes here. So from 0 to pi over 4, the cosine's on top. So I have from 0 to pi over 4, I'm going to do cosine of x minus sine of x. And then from pi over 4 to pi over 2, the sine of x is on top. So I'll do sine of x minus cosine of x. So, and once we find each piece, we're just going to add the two answers together. All right, let's find the first one. So what's the integral of cosine of x?
Isn't it secant x?
Nope. Cosine and sine are the ones that just keep going back and forth. So if you think about it in differentiation, we do sine of x, derivative of that is cosine of x, the derivative of that is negative sine of x, and then negative cosine of x. And then it repeats. So if we're doing integration, so this is derivatives, integration, we go the other direction. So the derivative or the integral of cosine of x is sine of x. And the integral of sine of x is negative cosine of x. And we're doing.
I'm not gonna lie to you. You told me I got a sheet of paper on my like in front of me, and that's all I'm gonna do is put these down because it's the one thing I hated about Calc 1 because I couldn't remember them to save my life.
Yep. The trig ones literally are going to be the number one thing you're going to put down on your piece of paper. And you're going to hate chapter 7 because there's a ton of trig. Because those are honestly, the polynomials and stuff like that for integration are pretty simple to do. It's the weird ones that are hard. And trigonometry is one of those ones that make things weird. So, but yeah, that's a nice little mental cheat sheet to remember those, how it reverses. It's kind of like the E of X. It's also E of X. It's just kind of confusing because it's the same darn thing. All right, so now we got to plug in our values to figure this out. So we've got sine of pi over 4 plus cosine of pi over 4. And then we have minus sine of 0 plus cosine of 0. So sine of pi over 4 and cosine of pi over 4 are both square root of 2 over 2. And then we have sine of 0 is 0, and cosine of 0 is 1. So we end up getting square root of 2 minus 1 for that side. So that's the first step. That's this half right over here.
Do we need to know that square root of 2 value, or is it all right to present numbers?
Nope, you can literally leave it just like that.
No, I'm meaning, let's say, do we have to know that sine of pi over 4, for example, square root of 2 over 2? Or can we plug that into the calculator?
The problem with plugging into the calculator is you're not going to get square root of 2 over 2.
Right.
You're going to get it as a decimal, which is going to be actually going to cause you more trouble than remembering square root of 2 over 2. One of the things that I would suggest on your little cheat sheet that you're going to have is have the unit circle. Or at least have the basic ones down, like the 0 to 90 or 0 to pi over 2 ones. So you have those basic ones that you can use, because they're going to come up a lot, and you really don't want this as a decimal answer because it's going to make it really messy in some situations. Because sometimes they literally will cancel each other out and make your life easy. So
All I'm finding out is that the hard part of calculus is trigonometry.
Yes. This is why when I teach pre-calculus, I drill trigonometry into your head, because that's all you're going to deal with. That's the number one mistake people make in calculus, is not the actual calculus stuff. It's the basic trig stuff that you just didn't get that well. So, yep. All right, so let's do the other one. So now we got to do the other one, the other side. So same concept. The integral of that is negative cosine of x minus sine of x. And we're doing that from pi over 4 to pi over 2. So we've got, actually, let's do it this way. So cosine of pi over 2 is 0, so that's negative 0, minus sine of pi over 2, which is 1, so minus 1. And then we got our cosine of pi over 4, which is going to be negative square root of 2 over 2. And sine, which is also going to be, oh, sorry, positive sign. I forgot my negative sign. Minus negative square root of 2 over 2. Minus square root of 2 over 2. So we get negative 1 plus square root of 2. So square root of 2 minus 1. So when we add those together, we get 2 square root of 2 minus 2 is my area of both curves. What you could have done is if you look at this shape and the way this curve works, you should have known there's a case of symmetry. So if you just got one half of it, you could have just doubled it to got the second half. So if you notice symmetry in it, you can actually use that to your advantage to figure out to make your life a little bit easier.
In this case, why did you add instead of subtracting?
Where?
You said at the end, we took the answers that we got for each of the integrals and added them together.
Oh, because they're two separate parts. I was subtracting inside of each one of them. So I did the for this one that I just did. It was sine of x minus the cosine of x. But the answers at the end were the two pieces. So I had this part over here and this part over here. So I'm going to add those two pieces together to get the final area.
Okay.
All right. Any more questions with this one before we go on to the last problem today? Most nights we will not go all the way till 6:40. Some nights we will. Some nights the lessons are just going to take a little longer to get through and whatnot. I'd try to end class between around like 6:15-ish or so. That's my goal. So this way I have some time at the end of class if people have questions and stuff like that, they can ask, and not everybody has to stick around. If you have no questions, you can obviously go. So. All right, last one. So we did the ones with the on the top and the bottom. That's pretty simple, straightforward, top minus the bottom. However, we also can look at equations that are, the area is going to be right to left. If we're looking at it in terms of y instead of in terms of x. So when we're looking at that, we're subtracting the right side minus the left side. But your equations have to be solved for x. So it's got to be x equals instead of y equals. The nice thing about doing this way is sometimes the problem, so like we're going to look at, actually, let's solve this one and we'll graph it first. So we can actually see what this one looks like. So my first equation is y equals x minus 1. If I solve that for x, that becomes x equals y plus 1. That one's pretty straightforward. The next one I have is y squared equals 2x plus 6. Now, if I had to solve this one for y, I'd have a square root in there, which means I'd have to look at a couple different things. Solving for x means I don't have to deal with the square root. So we get x equals y squared minus 6 divided by 2. Not that one. graph these two. All right. Other nice thing about Desmos is it easily allows you to graph for x instead of, or x equals instead of y equals. So here's my two equations. Something else. Plus one. Hold on 1 second. Sorry about that. Something's off. Hold on a second. Y squared minus 6. That won't make a difference. Oh, y plus 1, not y minus 1. There we go. I'm like, I know these answers come out to be whole numbers, not decimals. See, I even make the mistakes. Hold on one. Wife's cooking dinner and she's missing something. I'll be right back.
Did anyone else try to get access to that WebAssign thing?
I did. It works for me. I didn't have any issues, but this isn't I already have an account. You just have to make your account first.
Right, we don't gotta pay or anything?
I think you do. Kinda. Let me see.
Yeah, I think my payment from last semester is still carrying over. It didn't ask me for money when I,
Yeah, it might. And then there's like a free access version kind of thing where it like lets you do the stuff, but then you kind of look at the book and well, I don't know. I've never been a fan of some of the books, but that's just me. Because sometimes I don't buy them because some classes don't even use the books.
yeah.
Using the book. Although I am using web access, which you kind of get with the book, I think.
So I own the book. I bought it, but I don't know that I have access to the WebAssign because I just logged on and put in your code and now it says 14-day free trial.
Okay.
Did you buy the book new? It comes with like a little access code inside of it.
I did not.
Okay. I will ask if there's a way you can just get the web access code.
Okay.
I will find that out for you. But you got 2 weeks free, so that'll at least get you. You can at least get in, and I'll figure it out.
All right. Thanks.
And I will let you know. All right, let's finish this up.
Professor, real quick here. So on the black line, for example, which axis is which? I know we flipped them because, you know, now we're doing x equals, etc. But for example, if we were given a value of like y equals 0, right? X equals 1 on the black line, but here we're seeing it as like x equals -1. So I'm missing something, or do I just need to tilt my head to the left?
No, the x and y axes don't change.
Okay.
So if y is 0, so if x is 0, y is -1. So on your graph, when you graph it, the x and the y axis don't change. This is still my
Okay.
x axis going left to right. My y axis is still going up and down.
Got it. Okay, thank you.
So no problem. But yeah, the nice thing is like on the TI calculators, it's really hard to graph by y with x equals. And so normally we don't. So yeah, I can see how that can be a little bit confusing. The nice thing is though, is once we've solved them for y, our integration is going to be really simple. Where if we did it the other way around, I'd have the square root and everything else in there, which would make my integration, my calculations a lot more difficult to do. So when we're looking at this one, for example, my black line is going to be my right and my red line is going to be my left. And we're doing it from -1 to 5, because that'll be the intersection point for it. So now I'll delete that so you can see the graph. It had the equation solved and I wanted to solve them first. So when we're doing our integral for this one, we're doing the integral from -1 to 5, and we're going to do y plus 1 minus 1/2 y squared minus 3. And it's dy, not dx. All right. Let's do our integration. So we've got y plus 4 minus 1/2 y squared. Oh, yeah. So we got y squared over 2 plus 4y minus y squared over 6. And the -1 to 5.
That be cute, Professor?
Oh, wait, I screwed up. Good, find me my mistake, or actually ask your question. And then while there, you got the rest of you can find my mistake. What was your question?
No, that was regarding the mistake.
I know. What was your question? Oh, you caught my mistake. What is my mistake?
Oh, we didn't raise the power of the y squared.
Oh, that wasn't actually the mistake that I had. That's not the big mistake. I'm doing this whole problem in terms of y, right? What's my, then the range, or for, so -1 and 5 are not y's. That shouldn't have been -1 to 5. It should have been -2 to 4. Since we're doing it in y's, we have to use the y's, not the x's. But good catch on me not raising my power too. I did miss that one. All right. So we get 8 plus 16 minus 64 over 6. And then we got minus 2 minus 8 plus 4/3. Put all those together, and I get 18.
Why isn't the blue line your f of y?
Because you're going right to left. So in this case, the right side of the graph is the red line.
Okay.
Which, yes, is totally opposite of the way that you typically read a graph. You read left to right. But yeah, to make the calculations come out right. So it's not negative, it's right to left. The thing that all that's going to happen is if you swap these, if you screwed it up and put the blue one first, your answer would just come out to be negative 18. Which, if you think about it, doesn't make sense because I can't have negative area. So the only thing that changes is your sign.
Okay, thank you.
So no problem. I want to show you what this would look like, and I don't feel I'm not done to do it. So if we took the same problem, and this is going to be the last thing we do, and tried to solve it for y to do it in terms of x's, you can start to see what I would have. I would have y the square root of 2x plus 6 is on top. I'd have the negative version down the bottom. I now have actually two separate problems that I would have to do. I would have to do the square root of 2x plus 6 minus the negative 2 square root of 2x minus 6, do that integration there. And then I would have to do the integral of the square root of 2x plus 6 over minus the x minus 1 for that piece. So it's a lot more complicated to do. And that's why sometimes it's easier to solve for the x. And just
So for the first part on the left here, if we had gone, the brute force had done that part, would it have just been double? I guess there's like, if we're just looking at everything to the left of negative 1x, right? So we're effectively not even looking, you were just looking at that A1 area. What would the procedure have been from -3 to -1 and just that's it? Okay. We wouldn't be minusing, plus?
It ended up being plus because it's a negative, it's two negatives because you're subtracting the negative version of it. So yes, it would have ended up being just doubling it.
Okay.
But now you'd have to do the integral of the square root of 2x plus 6.
Right.
Which is a lot messier than what we just did. But yes, it's basically doubling the area on the top. So,
Thank you.
No problem. All right. Stop the recording.